Again, welcome to DSRT 734 class, Inferential Statistics in Decision Making. So in these lectures, we're going to discuss about probability, the addition rule. This is our third lecture in probability. So our main objective is to determine if two events are mutually exclusive, also using the addition rule to find the probability of two events. So we start with the mutually exclusive events. So here we have two events using the Venn diagram, event A and B, and another event A and B. But we can see that the first Venn diagram, the two events are mutually exclusive. The second Venn diagram, they are not mutually exclusive because at a particular time, we can have both event A and B occur at the same time. So this is the intersection of A and B. So we say two events A and B cannot occur at the same time, then they are mutually exclusive. When we have two events occurring at the same time, they are not mutually exclusive. So mutually exclusive, again, is our first Venn diagram. You can see event A and B, they occur separately. But our second Venn diagram, we can see that there's intersection between A and B, which is somewhere around here. So in this area, event A and B occur at the same time. Intersection means the two, in this case, A and B. So intersection of event A and B means the two events A and B occurred at the same time, which means they are not mutually exclusive. So let's do an example on this. So here they say we should decide if the events are mutually exclusive. So we have event A. We roll a 3 on a die. And then event B, we roll a 4 on a die. Are these two mutually exclusive? Can both of them occur at the same time? Of course, here we say mutually exclusive. The first event has one outcome, and thirdly, the second, which is 3. And then the second event also has one outcome, which is 4. There's no way that 3 and 4 can occur at the same time. So if I have a die and I roll it, I only get one side. Now, if there's a possibility that if I roll only one die, I can have both 4 and 3, then they are not mutually exclusive. But in this case, they are mutually exclusive. Now, this is different from if I roll 2 dice. If I roll 2 dice, I'll get 2 outcomes. One die will give me one outcome. The second die will give me another outcome. So here we are assuming that we are using only one die. I roll a die, I got 3. I roll the same die again, I get 4. So 3 and 4 cannot occur at the same time in one die. So it's mutually, again, exclusive. Mutually exclusive means two or more events that does not occur at the same time. Does not occur at the same time. So here they say we should decide if the following events are mutually exclusive. Randomly select a male student and randomly select a nursing major. No, this cannot be a mutually exclusive. Why? Because a male student also can be a nursing major. It can only be mutually exclusive if we are 100% sure that a male cannot be a nurse major. So let's see the answer. Not mutually exclusive. Why? The student can be a male and also can be a nursing major. Unless there's a rule in the school that all the nursing majors are female, there's no male. Then in this case, we say it's mutually exclusive. Again, the whole thing we want to understand here is that a mutually exclusive event is when the event does not occur at the same time, does not. So if I have event A, B, C, 3 events, and these 3 events can never occur at the same time, even 2 of them cannot, only one event can occur at a time, then it's mutually exclusive. So these 2 examples really help us a lot. The first one, we roll a die. When I roll a die, there's no way I can get 2 sides. I have to get only one. So it's mutually exclusive. This second example says we have a male student, we select a male student, and we randomly select a nursing major. But since there's no rule that a male cannot be a nursing major, we are assuming here male also, anybody can be a nurse major, male or female. So this is not mutually exclusive because we can select a male and at the same time, it's also a nursing major. So it's not mutually exclusive. So let's move to the addition rule. So in the addition rule, we have, this is where the mutual exclusive can even play a part here. For example, if I have event A and event B, and I want to find the probability of event A or B, or event A union B. Now, the probability that event A or B will occur is probability of A or B equal to probability of A plus B. Now, minus probability of A and B, which is probability of intersection of A and B. Now, if it's mutually exclusive, probability of A or B will be probability of A plus probability of B. That's it. We are subtracting probability of A and B, which is same as saying probability of intersection of A and B because we are assuming it occurs. So let's go to the diagram one more time, please. You see the diagram here. If this is mutually exclusive, to find the probability of A or B, it will be probability of A plus probability of B. That's it. The second diagram here, probability of A or B will be probability of A plus probability of B. But we have some intersection here, so it seems like we get A and B twice here. So that's why we have to subtract this area. So if it's not mutually exclusive, addition rule will be probability of A plus probability of B minus the intersection of A and B. But if it's mutually exclusive, then it will be probability of A plus probability of B. So let's go back again. So that's the rule here again. Here is not mutually exclusive. So that's what we said here. For mutually exclusive events, A and B, the rule can be simplified to probability of A or B is equal to probability of A plus probability of B. So if it's not mutually exclusive, addition rule said probability of A plus probability of A minus probability of A and B, because A and B can occur at the same time. Mutually exclusive means A and B cannot occur at the same time. So it will be probability of A plus probability of B. And can be extended to any number of mutually exclusive events. What we mean here is that we can have more than two. It can be probability of A or B or C. If it's mutually exclusive, to probability of A plus probability of B. If it's not, then we have to remove the intersection part out. So using the addition rule, here they say you select a card from a standard deck. We select a card from a standard deck. Find the probability that the card is 4 or an essay. So this means again, we have four card, space, diamond, heart, and club. The same thing, the essay also we have space, diamond, club, and heart. So these are the four possible for number 4 and for the essay. Now remember the total deck is 52. And they say here, select a card from standard deck, find the probability that the card is 4 or essay. Now you can see that this is mutually exclusive. Why is it mutually exclusive? Because when I take a card, let's say essay club, at the same time, it cannot be essay club and also be a diamond club. It cannot. Essay club means only one essay club. So this is mutually. So if it's mutually exclusive, and then we can see we have 4 and 4. 4 out of 52 plus 4 out of 52. So this will be our formula. Probability of getting 4 plus probability of getting essay. There's no intersection. We can One card cannot give us both 4 and essay. Each card is the 4, or it's an essay, it's a club, or it's a space. So this is again mutually exclusive. This is the most important thing we have to be very careful that the question will not tell you if it's mutually exclusive or not, but based on the conditions of the question, we may know. Here, a deck of 52 cards. We have cards. Cards always will be mutually exclusive because we cannot have one card with double face. Each card have its own one face. So the answer here will be again 8 by 52. 4 possible out of 52 plus 4 possible out of 52. And that gives us 0.154. Next question, they say we roll a die. We should find the probability of rolling number less than 3 or rolling an odd number. So rolling a number less than 3 means we can get 1 and 2. Less than 3, we can't go 3. The rolling an odd number is 3 out of the 6 because we have 6 values. 1 to 6, we have 3 even numbers, 2, 4, 6. We have 3 odd numbers, 1, 3, 5. So the events are not mutually exclusive. Why is not mutually exclusive? When I roll one die, I may get 1, which is mutually exclusive. Because I can't get 1 and 2 and 3. But 1 is also what? It's a odd number. So that means 2 events can take place at the same time. So that's why we say it's not mutually exclusive. Because the question says find the probability of rolling a number less than 3. If the question is up to here, find the probability of rolling a number less than 3, then this is mutually exclusive. We get 1, 2. Or rolling an odd number. Yes, this is not mutual because when I get 1, 1 is a odd number. When I get 2, 2 is not a odd number, but it's less than 3, but it's even number. But since one of the outcome can be 2 at the same time, 2 can, when I say 2, I mean 1 can be odd number and also it's less than 3. So this is not mutually exclusive. So this will be our answer here. Now probability of less than 3 plus probability of odd minus probability of less than 3 and odd. Probability of less than 3 and odd, since it's less than 3, we have only, well, first let's start with probability of less than 3 means we get only 2, 1 and 2. So it's 2 over 6. The total is 6 again. Plus probability of odd is 3 because 1, 3, 5 or 2, 4, 6 for odd even. So 3 by 6 is the probability of odd. Less than 3 is 2 by 6. Now we can say that minus 1, 6. Why? Because in this condition we have less than what? We have less than 3. So we have only 1 and 2. And out of 1 and 2, there's only one odd number, which is 1. So that's why we say minus 1, 6. Minus 1, 6. Again, we always have to look at the condition of the problem. I'm going back to the problem. Find the probability of rolling a number less than 3. If this is where we end, then we have a mutual exclusive. So it will be probability of having 1 plus probability of having 2. That's it. But they also said or rolling an odd number. So since we know 1 is an odd number, so when we were able to get 1, 1 will be less than 3, and also 1 is a odd number. So this is not mutually exclusive because 2 events take place. I mean, 2 outcome takes place. There's 2 outcome. When I toss my die and I get 1, it's a less than 3, and also it's a odd. So because of that, we are going to use the addition rule when it's not mutually exclusive. So it will be, again, probability of when it's less than 3 plus probability of when it's odd minus probability of when it's odd and also less than 3. So that will give us probability of less than 3. We have 2, 1 and 2. 2 by 6 plus, odd number is 3. So plus 3 over 6. Then less than 3 is only 1 and 2. Odd is only 1. So it will be 1, 6. So that's why here we have again 2, 6 when it's less than 3, plus 3, 6 when it's odd. Odd is 3 values. Then minus 1, 6. The condition said is less than 2, 3. We have only one value that is odd, so minus 1, 6. So our answer will be 4 over 6, which is 0.667. So let's see this example here. They say a frequency distribution shows the volume of cells in dollars and the number of months a cell representative reached each cell's level during the past 3 years. If this sales pattern continues, what is the probability that the sales representative will sell between 75,000 and 124,999 next month? So this is the table here, sales volume. 0 to 24,999 is 3, 25 to 4,995. And we keep going so we can see the pattern here. Now, in this question, we say, okay, we let A, got the question again. Let's go back to the question. The question said, what is the probability that the sales representative will sell between 75,124? So between 75,124,999. So between 7 and 9 here. So that's why first we look at the A's monthly sales between 75,999,999. Then we say, okay, B should be 100,000 to 124,999. This is the probability that we are looking for. So if this will be our event A, this will be our event B. So now we say probability of A or B is equal to probability of A plus probability of B. By looking at the table, this is of course a mutually exclusive. You can see each monthly different values that occurs. So we look at the month is already given, take 7 months, and the next one is 9. So it will be probability of A 7 by 36 plus 9 by 36. You do your calculation, we get 0.444. Again, the reason why we select those 2 rows as our event is based on the question given. Because the question said the frequency distribution, this is a frequency distribution table. We have the volume of cells in dollars and also the number of cells, the number of months a sales representative reach. This is the number of months during the past 3 years. Now the question says, what is the probability that the sales representative will sell between 75,000 here, which 7, to 124,999, which is 9, these 2. So I'll use this as our first event, this as our second event. This is mutually exclusive because the range are different. The range here cannot happen at the same time here. And the range of 75,999 cannot happen in 100,000 to 124,999. So this is mutually exclusive. So we just again had both. Why 36? Because it's 3 years. 3 years. If you had all this, you get 36. And based on the question also, they told us it's 3 years. Let's go back to the question somewhere. Yeah, past 3 years. This is the monthly, how many months they reach the sales volume in the 3 years period. So when you add all this, you get 36. That's why we're able to say this will be 7 by 36. This will be 9 by 36. Since they are mutually exclusive, we just had those 2 values, probability of A plus probability of B. Now another example here, a blood bank catalogs the type of blood given by donors during the last 5 days. So we have the last 5 days. A donor is selected at random. Find the probability the donor has type O or type A. So we have to look here, type O, A, B, and the total. So we have RH positive, negative. So our question here is to find the probability that the donor has type O or type A. Remember, type O total is 184. A is 164. The total for both RH positive and RH negative is 409. We have total for the RH negative 65. But here we're going to use the total. So you can see, question said probability that is O or A. Look the O section. The total O, they didn't say that whether it's RH positive or RH negative. They just say type O. So we use the total. So we have 184 from the total of everything. So probability that type O or type A, it will give me probability of type O, which is 184 over the 409, plus the probability of type A, which is 164 over 409. So that's what we have here. Again, we are using the total because based on the question, we were not given the condition whether it's RH positive or negative. Here, the question, donor is selected at random. Find the probability that the donor has type O or A. So type O total is 184. Type A total is 164. All the total together is 409. So the question is all. All means addition. N means multiplication. N means multiplication. So here we get 184 over 409 plus 164 over 409. Probability of type O or A. So O again is always addition, and multiplication is always N. So next again, they say find the probability that the donor has type. So this time he has what? Type B or is RH negative. So type B, which is here, and RH negative, which is here. So we are going to use the 8. So here they say the events are not mutually exclusive. And a donor can have type B blood and also be RH negative. So here we say probability of type B or RH negative, it will be because we cannot just say only type B or RH. We had probability of B. Probability of B here will give me 45,409 plus probability of RH negative. The RH negative is here 8. So it will be 8,409. We can't say that's it because some may have RH negative and also type B. So they get double. So this is not mutually exclusive. So we have to minus that. So we minus 8,409 from it. And the whole total of RH is 65. So we have 8,409, 6,5409, 4,5409. The 4,5409 will be the type B, probability of type B. So this is type B, 45 divided by 409, plus probability of RH negative. Probability of RH negative, RH total negative is 65. So 409. Then minus probability of type B and also RH negative. We want to subtract. When this is, say the rest 65 is occurring once, but we included the 8 in 65 here. So we have to remove the 8 of the 65 here. So it will be minus 48409. Okay, probability of B, 45 by 409, plus probability of RH negative, 65409. But the probability of B, we include the 8 here to make it 45. So we have to remove it since 8 also is in 65. So we remove 1 8. So it will be minus 8,409. So the answer will be 0.249. So this will be the summary of our lectures. Again, this lectures is two things we learn. What is mutually exclusive? How do we use it for addition rule? As we said, when two events are mutually exclusive, then addition rule means if, for example, it's only two events, probability of A or B will be probability of A plus probability of B. Now, if it's not mutually exclusive, which means the two events A and B can occur at the same time. Mutually exclusive means they cannot occur at the same time. If they can occur at the same time, they are not mutually exclusive. And the formula will be probability of A plus probability of B minus probability of A and B. So again, wish everybody the best and thank you for your time. Again, this is our third lectures. We have one more lectures in this this probability topic. So again, wish to see you in the next lectures.